Hello, my friends. It's the NOLA Mathman coming again for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
After watching this video, students will be able to do samples and studies in regards to the concept of statistics and probability. Concept we're looking at again is probability and statistics. The skill we're looking at is describing different samples and studies experimentally. So with no further ado, let's get into the lesson. So in the first example, we will identify each sample and suggest a population from which it was selected. We will classify the sample as simple, systematic, self-selected, convenient, stratified, and explain your reasoning. So in this first example, it deals with homeowner and topsoil. And so we have reasoned that the sample is the 1 inch of plug of topsoil from the backyard. And that is called a sample because that is what we're looking at in testing in this particular example. So that is our sample. Now the population from which it's selected is probably going to be all the topsoil in the backyard. So that's probably what we'll put for that. So we'll see what the NOLA Mathman comes up with. Yes, all of the topsoil in the backyard would be the population. So population is the general of everything we're looking for. The sample is specifically in that population what we're going to focus on. And so, and after that it says we want to classify the sample as simple, systematic, self-selected, convenient, or stratified. And then we have to explain the reason we pick one of those five choices. So we conclude this example with the topsoil that the sample is stratified. And why is it stratified? Well, it's stratified because backyard is divided into 5 equal sections. And that makes it like 5 equal sections, which makes it kind of stratified. That's the term. And again, all these terms for the definitions of simple, systematic, self-selected, convenience, and stratified, that's all in the textbook. And so you learn the details of which one each of those mean, and then you make a conclusion. And then that's what you will use when you reason your answer. So we say here, it's stratified because it's divided into 5 equal sections before the topsoil is randomly selected. So in other words, you break it into 5 equal sections and then you can randomly pick whatever parts of those sections, that topsoil that you decide to use. So we'll go to the second example. Hospitals administration's interested in opening a gym. They ask each member of the night shift emergency staff which gym they would use and what hours would they prefer to use it. So the sample we're looking at in this problem is each member of the night shift emergency room staff would be the sample, because that's the people we're going to be testing and asking questions and surveying. The population we're looking at, night shift emergency room staff. All of those people are possible choices in our survey. So the population deals with the possible people we can use in the survey. So again, population is more of a general thing. Samples are more specified within the bigger group. So that's important we know that. So when they ask to classify the sample, we decide that this sample is what we call a convenience sample. And so why is it going to be a convenience sample? Let's see what the NOLA Mathman comes up with. So we say it's a convenience sample because convenient sample because only those people can be involved in the survey because we specified the night shift emergency staff. So it's convenient. So we'll go to the third example. It says the center wants to know her approval rating among the constituents in the state. She has her staff obtain 1,000 responses to a telephone survey of registered voters in the state. So the sample here is the 1,000 responses to a telephone survey of the registered voters in that state. That will be our sample here. So this is what the NOLA Mathman is going to write, hopefully. We're on the same page here with him. And so, yeah, it says 1,000 responses to a telephone survey of registered voters in the state. In that senator state, to be specific. We want to be as specific as possible when we're trying to answer the questions here in regards to these samples. Now, the population is all the possible registered voters in the state. This sample is a simple random sample because each registered voter in the state is randomly selected. There's no narrow group that you deal with like in the other examples. It's just a random picking of registered voters in her state. Each registered voter in her state has an equal chance of being randomly selected. We've had an example of each of the different types of surveys in our 3 examples, so you gotta be very knowledgeable and confident in your definitions for the 5 different surveys that we will be dealing with in this section. So now we're going to do a different type of problem. We're going to identify each sample as biased or unbiased, and then we have to explain our reasoning for that. So in this problem, we have a company that produces motherboards of computers for computers and randomly selects 25 box motherboards out of a shipment of 1,500 and then tests to see if it meets specifications. So we conclude that this sample is unbiased because the 24 boxed motherboards, and this will give you a reasoning in this example, the difference between biased and unbiased. It's unbiased because the 25 box motherboards are randomly selected out of the 1,500, that's the shipment. And so there's no bias in which one to pick. It's just picked randomly out of the 1,500 motherboards that are in the shipment. And so for that reason, we would call this sample unbiased. So now we'll do another example. The first 100 people enter a county park on Thursday are asked their opinions on the proposed county ordinance that will allow dogs in county parks to go unleashed in certain designated areas. So we say this sample, unlike the last one, is biased because you're confining it to people who visit the county park on Thursdays. So let's see if the NOLA Mathman agrees with my logic here. We say it's biased because the group you are sampling only includes the people that visit the county park on Thursday. It doesn't deal with people who visit the county park on other days, or it doesn't deal with people who never visit the county park because you're not getting their opinions either. So it only includes the people who went to that county park on Thursday. So that would be considered a biased sample. And so we want to write this in complete sentences. As we have said with this Common Core, we want to be very complete in our thoughts. And so the NOLA Mathman writes everything in complete sentences. I know it might be a little tedious, but it actually is a very thorough way of doing your word problems. These are like word problems. So reading the whole response, the sample is biased because the group you are sampling only includes people who went to the county park on Thursday and is not representative of everyone who will vote on that county ordinance. So now we're doing another type where we will determine whether each situation is a survey, an observational study, or experiment, explain the reason. And again, these definitions are in the textbook. You can look them up through Google, and we will use examples to represent each of these different types. So the first situation with music preferences of a music store, the NOLA Mathman concludes that this situation is a survey because the data is collected. So since it is someone's opinions, we would consider this a survey as opposed to the other two, which are observational study and experiment. The key point is these are people's opinions, and usually in a survey you're looking at people's opinions. Now the second example we have here, administrators at a community library want to know the type of material patrons are likely to use. They record the type of media each patron uses. Now again, we would call this situation an observational study because the patrons are not aware that they are being studied. They're just being observed, and then they're recording those observations. So it's not like a survey where you're asking someone's opinion. You're just observing what they're doing, and you're making conclusions and generalizations from that. So we would call that an observational study, again, because the members of the study are unaware. And so we go to the last one to determine whether a school should purchase new computer software. The technology team divides the group into two groups. One group completes the activity using the current software. The other group completes using new software, and the students' actions are recorded and analyzed. Now, for sure, since there are two possible groups they're looking at, this is experiment, what we call experimental study, because the sample is divided into two groups doing two different things, and they observe the two different situations and make similarities and differences between the two. That's the definition of experiment, which if you do any type of higher level education involving chemistry or being a doctor or being an engineer, you will do a ton of experiments where you look at two different groups and you kind of analyze them. So this is, again, an experiment because the sample is divided into two groups, one using the current computer software and the other using the new computer software. And so by analyzing it, this would be a comparison, more like an experiment. Very good. So that kind of summarized. So we were able to look at each of the three different types of studies that you can do. And so as you see, we have a lot of different experiments and studies and different things that we were exposed to in this particular section. So we have mastered this concept of looking at samples and generating different types of studies. So until our next math adventure, this is the NOLA Mathman signing off. Have a blessed day.